investment decreases by 59% over 11 years period. What is effective annual rate? So this effective annual rate, we are dealing with R. We want to find R, which was inside of B, then inside of e to power of k. But before we get to the R, we need to know which formula we're going to use. We learned 3 formulas. So we have 3 formulas, correct? First one, the basic one was y equal to a multiplied by b to power of t. Then we learn y equal to a e to power of kt. And then we have y, or we can call it b, equal to initial 1 plus r over n to the power of nt. So it's very important to start, we have to pick a right formula. If you don't see if you see a continuous, there's a keyword continuous rate, we're going to use this formula. If we see a keyword, some word inside of the word problem, they talk about n times per year, the components monthly or yearly, whatever, then we're going to use this formula. If you don't see those keywords, we're going to use the basic one. So for sure, we're going to use this formula. Good. Now, so we're going to use that formula because we don't see a keyword continuously and components. And then we are looking for R. Inside of the B, we have R, which is 1 plus R. R might be positive, R might be negative, depends on decreasing, increasing. So that's enough information to start. So this investment decreases by 59%. So let's say we have, so in 11 years, let's say right now we have that much money in a stock market, for example. After 11 years, this will be decreases 59%. So how much money do we have inside of this bag? If 59% decrease, how much money do we have?
Um, 41%.
Very good. So we have, so this is very important. So decreases after 11 years. That means let's say this is my initial value. I'm going to call it P naught. Usually they label like this. After 11 years, how much P naught we're going to have? We're going to have 41% of P naught. Correct? So after this 11 years, we're going to have this much. So is this make sense? 0.41 P naught will be P of naught B to power 11. Behnaz, are you following me?
Yeah.
So this was initial value. This initial value at beginning, after 11 years, become 0.41% of the value, because decreases 59%. So I'm going to rewrite it again. 0.41 P naught equal to P naught B to power 11. So we know we are looking for R inside of this B. This P naught and that P naught, we can cancel it. We get 0.41 equal to B to power 11. How do I solve for B? Benas, how do I solve for B?
You have to take like root 11 from both
Very
sides.
nice. So we need to get rid of this 11. In order to get rid of that, we're going to make it to exponent 1 over 11 or root 11 or 11th root of the other side. But we leave it as 1 over 11. So we got B growth rate equal to 0.41 to the exponent 1 over 11. What do we get if we do this? We should get approximately 0.92214. Is that correct?
Yes.
So this is 92.214%. So this is our B. What is R? What is R? R will be 0.078786, which is approximately 7.786%. Any question? Ben, do you have question?
No, thank you.
How did you get the 41%? Again?
41%. So they said decreases 59%, correct? If for example, we have $100 at beginning, if initial money was $100, after 11 years, how much money we have? The 41.41 comes from 1 minus 0.59.
Can you just explain one more time how you went from the 92% to the R?
Okay, so Lindsay, I got your question here. You asked me.
Yeah, I think I understand that. Thank you.
If they said increase, you have to add 1 to it. If they say decrease, correct? So back to this one, we got B equal to 0.92214. We solved this algebraically, 0.41 to power 1 over 11. We know B equal to 1 plus R. Good. Because we are looking for effective rates, this is R. We need to solve for R. So in order to solve for r, if we subtract 1, what is b minus 1? We get negative 0.07786, correct? But we don't want to have a negative rate. We're going to say decreases. Instead of when you see negative, we're going to say decreases with this. That was your question? Somebody asked me.
Yes, thank you.
Megan. So we got negative, but the negative part, we're going to just say decreases by 7.786%. I'm sure your homework, you should not put negative number. You should ask you increasing or decreasing. When you put decreasing, mean you will take care of a negative sign. Let's have another one. So effective. So what we learn we have to pick a correct formula. Then if they said effective, when you see the word effective, then we are looking for R. Now I give you guys a formula. Q equal to, let's say this is a formula for some investments. What is effective annual rates? What is continuous growth rates? So this is in form of Q equal to A e to power k t, correct? This is a formula. This A is initial, K is a continuous growth rate. So they're asking you what is continuous growth rate? It will be 0.075. I just leave it in decimal form, but you need to make sure what homework asking you, make it in percentage or leave it in decimal. So that was very simple. I mean, this word coming from this formula. But the effective, again, we are dealing with R. This R is hidden inside of B. But there is no B in this formula. But if you remember, we said B equal to e to power of k. This equal to B. So e to power of 0.075, this is B. Can you guys calculate what is e to power 0.075? Lindsay, what did you get? You're mute.
I got 7.85.
Percent or
Yeah, percent, sorry.
like this. So this you got
Yeah.
0.0785. So
Yeah.
what is R now? One plus R equal to B. R will be B minus 1, which is 0.0785 minus 1. You will get negative, but the homework they ask you, is it increasing or decreasing? You're going to say decreasing, whatever the answer is here. Is that too much? No, correct? I mean, you take a note of this. I mean, in exam, I'm not gonna surprise you guys with super unique formula. No, you will see a question like this. If I ask you guys continuous growth rate, so whatever is here, you will pick effective, so you need to do little algebra.
For
I
the
have a question on
power,
Lucas, go ahead, Lucas.
for the power e, or for e to the power of 0.075, do you calculate that by doing 2.7?
No, just there should be a button E in your calculator.
Okay, got it.
Next one, some Clara, that was Clara,
it was the same question. Thank you.
Lucas. Okay. Yeah, there is a button in your, they said E. E to power of. Let's have another one, another example. So there's another homework question. Calculate the amount of money in a bank account if $1,000 deposited for 14 years. So let's say there is a bank here. You deposit $1,000 and this bank advertising 3% per year. How much money you have after 14 years? So for this, again, this is chapter 4 type of question. I mean, there's a word problem that only you have it in chapter 4 of this course. There is a 3 formulas you learn. You need to tell me, do you use y equal to a times b to power of t, y equal to a e to power kt, or b equal to p1 plus r over n to power nt. Which one do you want to use? So definitely this is out because we don't see the word continuously here. You can use the first one, or you can use the second one, the last one. Annually mean n equal to 1 and r equal to 3%. If you use the first formula, if you use the b, we're going to have initial 1,000 parenthesis 1 plus 0.03 to the power of 14. This gives you how much money you're going to have after 14 years. So this is R, the whole thing is B. Or you can plug it there, which is same thing, n equal to 1, n equal to 1. You will get the same equation. So it will be 1,000, 1.03 to power 14. And you don't want to mess up the calculation. You have to put 1.03 to power of 14 multiplied by 1,000. How much money are we going to have? Can you guys calculate this?
I think it's 1,512.59.
Okay, approximately 1,500, not bad. Wow, 3%. Okay, now part B. They said 3% continuously per year. So the word continuously, you're going to use y equal to initial 1,000 e 0.03 multiplied by 14. So growth rate here is 3%, 0.03. Can you guys calculate this to see what is that?
I got 1,512 or 21.96.
Okay, as you see, they are almost same. I mean, there's $21 extra, but usually they're almost same. It will be a little different. You're not going to get more than 100 or 200 extra. All right, so this is another type of homework that you will see. Any question here? No. Let's have another homework. An investment grows by 34% over 4-year period. What is the effective annual percent growth rate? So again, we are looking for R. And this R is hidden inside of B. First step, we need to know which formula to use. Is that A times B to power T, A e to power KT, P naught 1 plus R over N to power NT. Which one should we use? Behnaz will tell us.
Is it the first one?
Yes, I mean, we don't see a word continuously. We don't see a component sometimes per year. So we're gonna stay with the first one, which is great. We're gonna use this. Now we need to set it up. So this picking the right formula is great. Now we need to use what's going on. So this is 4 years, so we know T equal to 4. Let's say if we have an initial, I'm gonna use P naught, or you can say $100. Let's say your initial value was $100. If you put B to power of 4, now how much money you have? Lindsay. So let's say you have $100 after 4 years, 34%, growing 34% after 4 years. How much money we have?
$66.
$66 will be, I mean, is not going to be increasing. The $100 becomes $66 is not growing, it's decaying.
Will it be 1.33?
1 point. Good try. If they said decay, you were right. But we $66. So that means 34%. What is 34% of 100?
$34.
So that means after 4 years, you're gonna have your money plus $34. You're gonna have $134. So if it's P naught for any initial after 4 years, we're gonna have 1 plus 0.34 of P of naught. Or here will be 100. So I would suggest to use initial value as P naught for any value. Sometimes they say after 4 years the money get double, so you put 2 of P naught, or you put triple. So those are the word that, so here in this case, they said 34%, increasing by 34%, so it would be 1 plus 0.34. Or you can make an example, you have $100. After 4 years, this $100 become $134. What is B? So from here, we have 1.34 P naught equal to P naught B to power 4. You cancel this, you get B to power of 4 equal to 1.34. Good. If you do the same thing here, if you divide by 100, 134 divided by 100, again going to be 1.34. So you will get the same equation. So B to power of 4 equal to 1.34, then B will be 1.34 to the exponent of 1 over 4. And what is this equal to?
$1.050759.
1.0759. So this is B, but we are looking for effective annual percent. So this is percentage too, don't put decimal. So we have to subtract from 1. So B equal to 1 plus R. R will be B minus 1, which is 1.0759 minus 1 will be 0.0759, equivalent to 7.59%. Any question here? So the cheating way here is, for a question like this, if they said growth, you're gonna put 1 plus the rate. If they said decreasing, you're gonna put 1 minus this guy. For the other side, for this side. Let's have one more. This is similar to what we saw earlier. You said decreases. So decreases, that means your R at the end gonna be negative. And we are looking for effective. So we are looking for R. Which formula do we use? We're gonna use the first formula, A initial B to power of T, right? This initial value here, if I put 19 for the years, this initial value A after 19 years decreases 55%. So after 19 years, we're gonna have 0.45 or 45% of A equal to A B to power 19. In previous example, I used P naught. I put P O at the bottom, but now I use A. I know if this is initial, again, after 19 years, we're gonna have 45% of A. Some homework question, they might ask you, it will be half after 19 years. So you're gonna put half of A will be A B to power 19. So whatever they're asking, if this is 1/3 or 1/5, but here they said 55%. So I subtract 1 minus 55%, I get 45%. So now we have 0.45 A equal to A B to power 19. A will cancel. B to power 19 equal to 0.45. B will be 0.45 to power 1 over 19. So this is B. We're looking for effective. You will subtract it from 1. Then you get the answer. Tamir, are you okay?
Yeah.
It's too much, correct?
No, not really. It's kind of similar to the one
Yeah,
before.
all of them are similar. I mean, you need to see a pattern here, and then you will write a note for yourself. How do we attack question like this? How do we solve it? And that's
Yeah.
entire day going to college. That's, you have to have a good note sheet. And then in the exam, show me that you understand it. And I'm telling you guys, after this exam, you're not going to see a question like this. So only for next few days, you're going to see a couple questions like that in exam. Okay? Just try to like it for next few days and then dislike it. Then unfollow this one. All right, David? Good. Tahila? Good. All right. So this was, so if you find B, then 1 plus R equal to B. Then R will be 0.45 to power 1 over 19 minus 1. You will love this. I mean, this is a very advanced calculation. You need to make sure you're typing it correctly in your calculator. You're not gonna email me, oh, I'm right, but the computer didn't give me correct answer. You have to follow what they're asking. If it's a 2 decimal, 3 decimal, or exact value, just follow what they're asking you. All right, that was all the homework question that I picked. But let's see what. So I think Lindsay asked me 4.5, number 16, Lindsay. All right, so this wasn't recorded on the Zoom, but the solution is here. So part A, we use this formula. For part B, we use this one. There was another homework question. What number was it? Somebody said 4.5, number 30?
Number 16.
Same?
This is section 4.5 instead of 4.4.
But this was 4.5. Okay. 4.5. This was 4.5, number 16. Yours 4.4.
Yes, mine's 4.4.
Very good. So 4.4, we have an investment decreases. So an investment decreases by 65% over 16 years or 16-year period. At what effective, so we are looking for effective percent rate. So it's very important that they are looking for percentage format. So does it decrease? So we after a few examples that we solved, so you know we are looking for R, and we are using the formula y equal to a times b to power of t. Correct? They said decreases. That means this initial value will be 35% of the initial when I apply 16 here. So after 16 years, we're gonna have 35% of that. Does that make sense? Yeah. So we see the decrease. So the initial value is gone. I know you guys say, well, what kind of investment is this? But, well, people, mostly in the stock market, they're going to go down probably. Or some other type of investment. So now we're going to solve for B and subtract 1 to get R. So B to power of 16 equal to 0.35. B equal to 0.35 to power 1 over 16. Whatever is that, you subtract from 1. You will get negative because it's decreasing, but you will put in percentage. All right. So there's no more homework.
Can you do 28?
28. What chapter? What section?
Section 4.5.
4.5. 28.
Mm-hmm.
Just don't get used to, guys. Don't get used to I'm solving all the homework. But again, my goal is you guys learn the technique. So in this home question, this is 4.5, number 28. They're saying from time t equal to 0, t is in the years, $1,300 deposited in a bank. Account grows. The formula for the bank is B equal to 1,300 e to power 0.05 t. So also the bank gives you this formula. That means this is your initial. If you want to know how much money do you have after 1 year, if you plug t equal to 1, so you will see how much money you have after 1 year. But part A, they're asking what is the balance? What is the balance Wow. At the end of 85 years, we all did. Why that many years? Correct, they said 85 years. Well, I don't care how much money is there because I'm not here. 1300 e to power 0.05 times 85, correct? This gives you how much money you're gonna have. Correct? In part B, so you do calculate this one. You calculate it, and I don't want you guys lose point the way you're gonna calculate it. Okay, you guys should calculate. I mean, there is an E button. You're gonna calculate this two first, 0.05 multiplied by 85. Whatever is that, you're gonna plug it to the e to power of this. Then whatever is this, you're gonna multiply it by 1300. Should be very careful. The way we think is different the way robot or the calculator calculate. All right, for part B, they said when does the balance first go over 50,000? So now they're saying when the balance gonna be, when the balance will be 50,000. This is a very good homework question to go to chapter 5. So how do we solve this? So here we are looking for t, correct? We're looking for time. This b right now, we have the b. This b become 50,000. So 50,000 equal to 1300 e to power 0.05 t. They're saying, what is this t? What value for t you plug that when you calculate this, you will get 50,000. How do we solve it? I don't know why this question is here, but we should be able to approximate it. But using log and natural log, we definitely can solve it. So let's do this. So we are, let me write it here. So we have 50,000 equal to 1300 e to power 0.05 t. So we are looking for this t that's unknown. Yesterday we talked about how do we solve exponential equation. One of the technique we learned, example 5 to power x plus 3 equal to 125. How do we solve for the x? I mean, the question is solving. So we're gonna solve, you categorize it. How do we solve it? There's a linear, quadratic, cubic. What type of equation is this? What we see x on top. That's the exponent. In order to solve the exponent, one technique is to make the both sides have the same base. So not all the time is doable, but this example, 125 is 5 cubed. That means 5 to power x plus 3 equal to 5 cubed. This should be same. Correct? That means x plus 3 equal to 3. Well, such a good example. This x should be 0 here. When you solve it, you get 0. So the point is we make them same base. So now we're going to solve for this t here. Can I make them same base? No, there's no way I can make them same base. But before we go to the same base, I can divide both sides by 1300. I get 50,000 divided by 1300 will be e to power 0.05t. It's gone. So 500 over 13 equal to e to power 0.05t. What is 500 divided by 13?
It's 38.461.
Okay. In this homework, they said approximated. Good. I don't know why there is a question like this in the homework, but we approximated, you can say t equal to like 80. I just randomly pick 80. If I put 80 here, what is e to power 0.05 times 80? Is it approximately equal to 38.46? If it's not, you put t equal to 70. I know it's horrible because you don't know log, but you're gonna learn log soon. But that's how you're gonna estimate this one. I think should be around 72.99, wow. T equal to 72.99. If that's a homework question, that's 72.99. Question?
So you just plug in numbers to find t?
I would suggest, I mean, you're gonna learn natural log in 10 minutes. You're gonna use that. So I'm gonna keep this question here. I'm gonna solve it.
For mine, it said it was wrong, so I have slightly different numbers. Should I just plug in other numbers?
What number do you have? I mean, what equation do you have?
I have, let's see, $1,400 is the initial value, and then 0.03 is R.
R or
K.
0
0.03 instead of 0.05.
and 50,000 is other side.
1,400.
Now what is the after?
Okay. Yeah, it's 50,000.
Okay. So let's do this into the log. Let's help you out. So we have 50,000 equal to 1,400 e to power 0.03 t. I divided by 1,400, divide by 1,400. I get 500 over 14 equal to e to power 0.03 t. What is 500 divided by?
35.714.
31 point,
35.
35 point.
714.
This equal to e to power 0.03 t. In next 10 minutes, you're gonna learn. I mean, it might be you might be able to do it by graphing calculator, but we don't want to go there. You take a ln here, and you take a ln this side. In your calculator, there is an ln button. They call it natural log. So this side will be 0.03 t. Can you tell me what is ln of 35.714.
It says 3.575 or 5.76.
Did you put ln parenthesis 35 and you get 3 point?
3.576, yes.
Not divided by 0.03.
I got 119.18.
Yeah, that's your answer.
Okay, thank you.
119 point. So around 119. All right. Cool. So that was a good example to go to the log. Chapter 5. Are you guys ready or tired? Not tired, yeah? So we are dealing with new functions, not linear, not quadratic, not exponential. It's related to exponential, but they call it logarithm. Same as, but for adding, so adding, subtracting, dividing, multiplying, square roots. So all of them are operations that you know it very well. If I ask you what is 5 plus 8, so this addition, you apply the addition rule. If I say what is 19 multiplied by 3, you're using multiplication rule. So you know it very well. Now I'm going to add another type of operation, which is log. Here we had exponent to like a to power n. So you know them very well. This is brand new, for example. Okay, 5 plus 8, the answer is 13. If I ask you guys what is log of like 100 base 10, the answer is 2. So there is a logic going on. So this log takes 2 number, and this will be the output. Same as addition, it gets 2 number, we get 1 output. So log takes 2 number as well. So now I'm going to make more example. Log 100 base 10, we said is 2. Now we have log 125 base 5 equal to 3. Log 16 base 2 equal to, or base 4 equal to 2. So do you guys see a logic here why log of 125? So this is log, gets a number here, and there is a base on the bottom, they call base. Somebody read this one, log 525. But the way I read it, I read log of 125 base 5, the answer is 3. Log of 16 base 4, the answer is 2. What is log of 25 base 5?
2.
2.
Very good. So the logic is, the logic behind the log, the answer that you're going to get, 5 to the power of this, going to go this number. 10 to the power of 2 will be 100. 5 to the power of 2 is 25. So you will see some homework question only for, they give you one unknown and you need to solve that. For example, log of 32 what base equal to 5?
2.
So again, like a puzzle, you know the relationship between all the input of the log. So the first formula for the log is log of A base B equal to C, correct? For any AB, if the answer is C, this one, it will be A will be B to the power of C. So B to the power of C, the answer will be A. That's what we have. If I give you exponent, you should be able to make this one to log as well. So it's a 2 ways. If I give you log, you can give me exponent. If I give you exponent, you should be able to give me to log. So in order to solve this x, good, so there are equations in logarithm. So they say solve, and I give you log. The foundation is we make a log in exponential. If I apply this rule, I'm going to have 32 equal to x to the power of 5. So now I'm going to look at this one. Having a log in equation is kind of scary. So because log, you think that's the unknown too. But making it to exponent with other log, little more welcoming. So now 32 equal to x to power 5. If you don't see the answer, you need to simplify 32. 32 is 2 to the power of 5. How do I know it? I mean, by making prime factorization. So 2 to the power of 5 is 2 to the power of 5 equal to x to the power of 5. The exponent are same, then the base must be same. So x equal to 2. There are few form properties of log that you need to learn or review. The first one was log of A base B equal to C. This equal A equal to B to power of C. Now log of A base A, the answer is 1. Example, what is log of 15 base 15? The answer is 1. Log of 3,000 base 3,000. Good. If they're same, the answer is 1. So this is a property. We can prove it, or you memorize it. What is log of 1 to any base?
Zero.
Log of 1 to any base, the answer is 0. So it's another property. Let's say if I ask you guys to prove it, you put x over here and you solve for x. Make this one to exponential form. 1 will be a to power of x. A to power what number is 1? A to power 0 gives you 1. So x must be 0. If we have so you learn log of, we have two formula, log of 1 and log of A base A. We have a common logarithm. in your calculator, if I ask you guys evaluate log of 50, you can do it. And there is no base here. There is no place in probably the very advanced calculator, if it's brand new, I mean, very up-to-date calculator might ask you what is the base, but most of the calculator doesn't have the base. That means this base is 10. If you don't see a base, that means base is 10, and they call it common logarithm. Common logarithm. So what is log of 50 base 10? You need to use a calculator. I mean, you cannot, I mean, if you put this one x, you cannot say 50 equal 10 to the power x. 10 to the power what number is 50? We are not able to do it by hand. It has to be a calculator. So common logarithm, the base is 10. Can you guys tell me what is log of 10? David?
I'm not sure.
What is the base of this log? Do we see a base? No, the base is invisible 10. Good. So what is log of 10? 10?
The 1 or 1.
Yes. So anytime you don't see a base for the log, you should be happy because you can use a calculator. Another formula for the log is if we have a log of a to the power of k, and here is like a base b. You can write this one as this exponent can go in front of the log. You can write this one k log of a base b. So this is a property. Anytime you see this, you can write it as this, or you see this one, you can write it as that one. Example, what is the value of log of 10 to the power of 5? So this is my A, and the B here is invisible, which is 10. What is the answer there?
Is it 5?
Yeah. So we apply this formula, this exponent will be front of log. It will be 5 log of 10 base 10. Log of 10 base 10, the answer is 1. 5 times 1 is 5. What is log of 1 over, no, root 10? What is this equal to?
Is it 1/2?
Very good. So in order to answer this one, radical 10 is same as 10 to power 1/2. So I'm going to write log 10 to power 1/2 base 10. I mean, here is invisible 10. You can write. This exponent's going to go over here. We have 1/2 log of 10, 10. The answer is 1/2. Very good. What is log of negative hundreds base 10?
Is that impossible?
Using calculator?
No, it's just that you can't like square something and get a negative number.
Very nice. Very nice. So we said log is a function. So this is like a factory. Inside of the factory is a log base 10. For example, 10 goes 1, 100, we get 2, 1,000, we get 3. This factory, the log, never gonna accept negative number. So the domain of like a log of x, this x must be greater than 0. Not even 0, has to be more than 0. The fun, compare with effective rates. One fancy formula for you guys. If we have a number, a, to the exponent log of, for example, k base a, the answer of this will be k. This is super important. For example, 5 to power of log of x base 5. This is very advanced. 5 to exponent log of x base 5, the answer is x, right? As long as these two are same, this will pop up.
What if they're not the same? Or will we never?
I'm not gonna ask you guys. If there's a question like this, so there should be a trick to it to simplify to get to that. All right, so this is the answer is 2. Log of 0.001. This one equal to, so the base is 10. Well, you can use a calculator. If it's base 10, your calculator can calculate it. But you need to know the algebraically, this is same as log of 0.001. It looks like 10 to power of -3. Apply exponent, this -3 gonna come over here. We have -3 log of 10, 10. The answer is -3. Now let's see what is natural log. So common log was base 10. For example, log of a equal to c, a equal to 10 to power of c, because there's invisible 10 here. Natural log, we have log of a. If the base of log is e, the e that you learn on chapter 4, 2.7, if the base is e, because in calculus and chemistry we use base e a lot, this is too much to write. We made this one to ln of a. So ln of a, it would be same as log of a base e. So natural log is type of log that has a base e. And your calculator has a log, base 10, and there is a ln, which is base e. All the property that you know about all the property in logarithm, it will be same as natural log. For example, what is ln of e?
Isn't that just log?
What's that?
Just log?
Yeah, ln of e, this is used to be log of e base e. What's the answer? If you see log of e base e,
1.
1, right? So ln of e is 1 because ln has invisible base e. What is ln of 1?
Is it E?
A,
0?
E, B, 0, C, 1, D, D. Which one do you think is correct? Lindsay, you're mute.
I said 0.
Very good. The answer is 0.
Mm.
Again, we know log of 1 to any base, the answer is 0. If the base is e, again is 0. So ln of 1 is 0. So one more time, the ln of, for example, a, this is exactly same as log of a base e. So we use, because natural log, so inside of here, you can always picture a base e. Ln of a equal to b, then a equal to e to power of b. Also, you can go the other direction. That's the first formula. So what is ln of e to power of 5? Log of a to power of m was m log of a, any base. Ln of a to power of m will be m ln of a. So we can apply the same formula. So this 5 will go over here. We have 5 ln of e. Ln of e equal to 1, so the answer is 5. I will stop here. It would be too much for you guys. But we are in chapter 5, so your exam will cover most of the chapter 5. All right. You will see a practice exam. You will see homework for chapter 5. All right. Any question?